Okay, so with question 1, we are now doing, as we said before, we don't think it's really induction per se that we are practicing. It is more just algebra and fooling around. And this one has got factorials, and the thing that you need to realise, you've all seen factorials before? If you haven't, we know that, or we should know that factorial, oops, let's have a decent colour there, 5 factorial just means it's 5 times 4 times 3 times 2 times 1. Agreed? For us, when we're doing these, some of the handy things to know would be that k factorial would be k times k take 1, k take 2, all the way 2 times 1. Yes? And of course, if I wanted to get k plus 1 factorial, would you agree that that would be k plus 1 times k factorial? Yeah, makes sense. Go back to the numbers. Like if I have, we've got 5 factorial there, but if I then times that by 6 times by 6, well, that means it's 6 factorial. Agree? So knowing that, hopefully, this stuff shouldn't be too bad. But, you know, we've always got our fingers crossed. So let's start with A and see how we go. You should be staying a step ahead of me. I'm just going to write stuff, you know, do the PN, P1 and so on. So if you are people playing at home, I've been a bit naughty. I haven't done the PN. We're assuming P1 is true, otherwise it would be a defunct. If you don't know how to prove the left-hand side and right-hand side of that, I'll come around and see you. We've done the assume PK, right? So wherever n was, we've just replaced it with k. Then we've done the prove k plus 1. So I've done my, remember I like to include my kth term, then my k plus first term. And wherever k is, I have n, I've replaced it with k plus 1, so that's why that's k plus 2 factorial, right? Okay, here comes actual maths. So left-hand side, all of that, do we agree, is indeed pk. So I've got k plus 1 factorial, take 1, plus what I've got left over here, which is k plus 1 factorial. And yes, we're saying using pk. All right, so everything to that point was yeah, haven't had to think really at all. What are some of the things that you notice here? I think 2 things that you notice. 1, yes, what'd you say? Okay, excellent. The first thing that we notice is there's a common factor of k plus 1 factorial for 2 terms. Why am I not worried that it hasn't got a common factor with this minus 1? Because I need the minus 1 out the end, just like so. So that's good. We're going to leave it out there. We've got it. Awesome. All right. We look at what we're trying to do. We're trying to get a k plus 2 factorial. Now, hopefully we know what is k plus 2 factorial. Yeah, so k plus, I'm going to rub this out in a minute because I'm going to use the space. But k plus 2 factorial, would you agree, is going to be k plus 2 times k plus 1 factorial. Yeah? K plus 3 factorial would be k plus 3 times k plus 2 factorial. So the fact that we've got a k plus 1 factorial is good. We're hoping that we're going to have this simplification of k plus 2 when we're left. Anyway, so I'm going to pull out my k plus 1 factorial. Our main concern is that we are showing enough working and enough of our knowledge to go, yes, the marker can see that we know we're not just making up stuff. All right, so when I pull out this k plus 1, what am I left with? 1 plus, because if I'm pulling out the k plus 1 as a common factor, k plus 1 factorial times 1 gives me the k plus 1 factorial. If I didn't have it there, I'd be stuffed. And then I pull it out from here, and I've got plus k plus 1, the minus 1 is sitting at the end, and lo and behold, we've got k plus 1 factorial. 1 plus k plus 1 is k plus 2, and we know that this is now k plus 2 factorial. If this was k plus 1 factorial times k plus 3, we could not say that's k plus 3 factorial because we're missing k plus 2. But this is like the next term. Does that make sense? So now we've got k plus 2 factorial. That is our right-hand side. We're all good to go here. Therefore, pk plus 1 is true. Put the statement. Anyone want to feel like saying the statement? No? Since P1 is true and pk plus 1 is true whenever pk is true, Pn is true for all, and they're doing it, they're saying it, it's cute. All right. So, your turn now. Do we feel confident to go with B? It's got factorials and it's got fractions. And it will have some factorization. It's a triple F problem. We're now doing B. And I want to reiterate, I am doing a very sloppy job for the first bit. So you need to make sure you write Pn. Write the fact that n is dung dung. Then you need to do P1. You must write, therefore P1 is true, and show all of that. Again, I'm doing very sloppy. You need to write, assume Pk is true. Right? Now we're going to prove Pk plus 1. I'm just shortening it so you don't have to wait for me all the time. Here we go. I'd appreciate if you either listen or you are working silently if you got this correct already. But please don't go, I'm not going to listen because I want to do it. I've given you enough time. We've got to do a heads up. All right. So this to here is our Pk. And everyone is compared. We're all happy that you got that Pk and Pk plus 1. Awesome. All right. So we can replace that with k plus 1 factorial. Take 1 all over k plus 1 factorial. I hope you guys are also realizing it's really handy if you give yourself some space. You are writing big enough so you can read your work. Some of you have gone to lined books. That's great. The graph ones, a little bit too small sometimes. Anyway, okay, we've got that, and we're just going to keep in mind what our right-hand side is. So remember, you're either looking at the actual thing here that we're trying to do or up here, but when I see this, I want a common denominator, right? We've got two separate fractions. I want a common denominator. Now, what would be my common denominator? No. So someone would just saying k plus 1 factorial, k plus 2 factorial. Now, you could do that, but that's like if you had, let's say, don't even need 8. Let's say if we had 7 over 12 plus 1 over 24, that would be akin to going, well, my common denominator is 12 times 24. Now, you're right. That is right. But we can make our life a little bit easier here if we went, well, hang on, 12 goes into 24. So this is when we're thinking about our factorial. And would you agree that k plus 2 factorial is k plus 2 times k plus 1 factorial? Do we agree? So, in order to turn this k plus 1 factorial into k plus 2 factorial, what can we do? What do I have to times that by? Yeah, I have to times it by. I'm going to do it very close here. Oh, come on. So I'm going to times that. Oh! Palm on board. I'm timesing that by k plus 2. And what I do to the bottom, I have to do to the top, right, all of that. Okay, so now what do we end up with? We've got k plus 1 factorial times k plus 2. What's that, Ollie? k plus 2 factorial minus 1 lot of k plus 2 plus k plus 1, and it's all over k plus 2 factorial, right? Now, I'm not saying always. I'll just stop because people I just saw give me a funny face. Up here, I'm hoping that what happens, I've got my k plus 2 factorial here. I'm hoping that all of this will now cancel to give me minus 1. Let's cross our fingers and hope. We've got k plus 2 factorial. Minus 1 times k is minus k. Minus 1 times 2 is minus 2. Plus k plus 1. Have we got smiles on our faces? Or relief? Either one. Okay, so minus k plus k, and minus 2 plus 1 is minus 1, and that, correct me if I'm wrong, is what we needed. Therefore, P of k plus 1 true. I didn't even put the assuming pk up there. Make sure, put your statement, all good. Yes? Yes, Ollie? Huh? Lamb did forget to tell me. I've given up on him. I think we have to... I don't know. Well, Lamb, your job. Okay. Hence, find the sum of this in rational form. So I think that's reasonably straightforward. Would you agree? What would we have to make n? Michelle, have you done this? So you would make n 9 and pop it in here, and away you go. Everyone happy with that? Because to get this to be 10 factorial, n would have to be 9. So to go all of that added together, we'll then just put 9 in here and work it out. Yeah? Okay. Write it out. And I'd like to think I don't have to go through this with you. You would be able to read it your good self. But sometimes when I ask you to do that, it doesn't happen. So please, all right, consider the matrix. Find b squared, b cubed, b to the 4. Now, in the olden days, we'd have to do that by ourselves. What could you do? You can put that on the calculator. I warn you, all I have to do to make your calculators useless is I can put a n in there somewhere. Evil. So when it's like this, absolutely, your time is precious. Use technology. But be aware that you do need to, down here, you've got some k's. You'll have to do row by column anyway. So they've done. And they're then going, can you see a pattern of what's going on? So b squared, we had 4 minus 3, 1. Compare it to this. When we had b cubed, that became an 8. You noticing anything about that top left-hand corner? When it was b to the 4, it was? So would you be happy to say, oh, hang on, this is 2 to the n. Whatever your power is, it was 2 to that power. Okay? The 0 always stayed the same. The 1 in the right hand was always the same. What happened here? You had to do a little bit of, fooling around. Minus 3, minus 7, and minus 15. Hey, that was this thing. Less 1 and negative. So these are great questions when you think of our performance standards when it says, make a conjecture and prove it. Great questions. Right? So you actually have to come up with this. Not a great question if you can't actually get the conjecture, because then the rest of the question's stuffed. So do make sure we practice. All right? We can see, so here's our conjecture. We say b to the n equals that. Sorry, those at home pointing. And then we've got n equals 1, so we still have to do our P1. So same process. We're going to assume PK. So all we have to do is go back up here, wherever n is, we replace with k. We now want to prove p to the k plus 1. So how do we get b to the k plus 1? It's b times bk. can I ask, what if Tristan, instead of saying B times BK, what if he did B to the K times B? It will work. I know what you mean. So you're shaking your head because you went, hey, we know AB doesn't necessarily equal BA. In this case, it's actually going to be okay. Because B times B to the K times you by the same base, add the powers. If you did it the other way around, it works too. So you could just go, I tend to go B to the K times B anyway. And now you can see we have to go row by column. This is another example where you might go, oh my God, this is so obvious. I just want to jump steps. Don't. Because again, we should know what we're proving. So put your steps in. So row by column. So you can see 2 times 2 to the K. They actually wrote it. 0 times anything is 0, so that's okay. 2 times 0, 0. 0 times 1, 0. Get the gist? And then we've got 2 to the 1 times 2 to the K, so we've got that. I would have added in here, I would have actually done a PK plus 1, so I know what I'm trying to prove. So I would have already had P B to the K plus 1 equals 2 to the K plus 1, 0, 1 take 2 to the K plus 1, and 1. So I know that's what I'm heading towards. Yeah? So when you're doing this, insert a PK plus 1 statement. But can you see it's the same thing? So row by column. So I'm going to ask you to do that over the weekend. We have got 15 minutes and I'm hoping we can do question 6 from before and even start 6E. All right, let's go.